Right, welcome to question 4 of the year 13. Oh, well, am I never going to get this right? Question 4, year 13, 2018 mock. How hard can it be? And I owe some of you an extra mark, I have a feeling, because there's 2 marks for this. Calculate the relative atomic mass of titanium in the sample above. Okay, nice and easy. So it's the mass times the abundance. Plus the mass times the abundance, plus the mass times the abundance, plus the mass times the abundance, all over 100. And if you put the answer to 1 decimal place, you are owed 2 marks. I probably might have chipped you 1. Sorry. Come and see me, and I'll adjust it before we get the final results in from the other mock too. Write an equation including state symbols. God, they even wrote it in for you to show how an atom of titanium is ionized by electron impact, and give the MZ value of the ion that would reach the detector first. Okay, so big ups to all the people that did the equation and didn't put the state symbols in. And it's the skinny one that travels the fastest, isn't it? Yes. Calculate the mass in kilograms of 1 atom of 49 Ti. Well, it's just going to be 49 divided by 6.02 times 10 to the 23, isn't it? Except that it wants it in kilograms, not grams, and remember that that is in grams, so we're going to have to divide it again by 1,000. And then we're going to have to put it in the number of significant figures that are the data with the least amount of significant figures has in our question. And that is 2 significant figures there. So it's 8.1 times 10 to the minus 26. I'm not supposed to say that. Mind. Question 4. There's only 3 marks for this because really it's quite easy. As long as you're comfortable rearranging equations. We're going to be looking, what we're looking at, we need to calculate the time of flight of the 47 Ti ion. Right, what have we got then? We've got E, we've got that. We know the mass, or can work out the mass. Okay, we've got the time of flight for 49 Ti ion there. Now, there's more elegant ways of doing this, but the way I would do it is just to work out D. If I know D, then I can use D to plug into a time of flight equation for a 47 Ti ion. So if T equals D square root blah blah blah, T over the square root of M over 2E equals D. And then once I know D, I can do T equals D square root of the mass of the 47 Ti ion over 2E. Where are we going to fall down? We are going to forget, when we're calculating the mass of the 47 Ti ion, 47 Ti ion mass, we've got to put that in kilograms, so we're going to have to go 47 over Avogadro's, let's just call it that, and then the whole lot over 1,000. And I think that was as difficult as it got. Appropriate number of significant figures, right? Well, look, we've got 4 there, we've got 4 there, but we've only got 2 there. So we need 2 derived for our mass for the Ti49 as well. 2 there, there he is. So the correct number of significant figures will be 2. Is that it? Yeah, that's it.